Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set 3 of 5 good problems on the chapter of direct and inverse variation. Uh, I have already solved 10 hot problems, that is 10 good problems on this chapter in the previous two videos, that is set 1 and set 2. I hope if you have not watched those videos, then I strongly suggest that you also watch those videos as well. And if you can also watch my theoretical videos in the other playlist, that is CBSE Maths 8 RS Agarwal, where I thoroughly discussed and solved textbook problems on this chapter following the textbook of author RS Agarwal. So this video is part of the playlist Maths 8 Hot. HOT stands for High Order Thinking, where I come up with 5 good problems and solve it from every chapter as and when they are completed in the other playlist, that is CBSE Maths 8 or S. Agarwal. If you are new to my channel or not yet subscribed, and if you are visiting my channel for the first time or visiting my video for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 3 on the chapter of direct and inverse variation. Okay, so I have the problems, set of 5 problems on the left hand side. I hope the fonts are big enough so that you can read them properly. The link to the PDF of these 5 good problems will also be there in the description. You can check the PDF from that link as well. While I will be solving the problems on the right hand side, I will pause for a few seconds after solving a problem so that you can take a screenshot of the solution if you think it will help you. Okay. Uh, the first problem says that for an amount of water kept in a cylindrical jar, the square of radius of the base and the height of the water are inversely proportional to each other. What will be the height when radius is 2r if the height is h when radius is r? For an amount of water kept in a cylindrical jar, the square of radius of the base, that is the base of the cylindrical jar, and the height of the water, the height of the water, the height of the amount of water is fixed, it is not changing. So for a specific volume of water, it is saying that the height of the level of the water in the jar and the radius of the base of the jar, they are inversely proportional to each other. Okay, so let's if we consider uh, r if we consider r to be the radius of base of the jar and small h the quantity we are considering, the two quantities h, the r and h, where r represents the radius of the base of the jar and the small h represents the height. Now the radius, the no units are given, so we need not consider any unit, and the let's say small h represents the height of the water in the jar. Now we must and it is also given that the square of radius of the base and the height of the water are inversely proportional to each other. So we can say the square of the radius is r square is inversely proportional to height. So we have this. R square is inversely proportional to h. We have this. Now from here we can say, since these two quantities, that is r square and h, are inversely proportional to each other, their product must be constant. So we can say r square h will be a constant. We don't know the constant, but it will be some constant, which is known as the constant of proportion or variation. Okay. Now it is saying that what will be the height when radius is 2 twice capital R if the height is capital H when radius is capital R. So if we try to create a table from the given data, so we have H, R and H. So it is given that when the radius is R, capital R, the height is H. Now it is asking what will be the height when the radius is 2R. So if the radius is 2R, what will be the height? We have to find the height. Now let's assume the height when the radius is twice R, let the height be H1. Let the height be H1. We always assume the naming convention of the unknown quantities is like since the quantities in this problem are we are assuming to be smaller than H, if we need to consider any unknown of the quantity R, we name them as R1, R2, R3, etc. Similarly, for the quantity H, any unknown, if we assume, we name them as H1, H2, H3, etc. So we have assumed that the height of the water will be H1 when the radius of the base of the jar is 2R. So from here, now we can say, since these two quantities R and H are inversely proportional to each other, we must have R square H equals to constant. That is, the product of R square and H of the corresponding values will be equal. So we can say that R square and H should be equal to twice R square and H1. So from here we get R square H is equal to square of twice R is 4R square H1. So this implies H1 will be equal to R square H by 4R square. So R square gets cancels out and we are left with H by 4. So the height of the water level in the jar will be H by 4 when the base of the radius, when the radius of the base is twice capital R, and hence the correct choice is D. Okay, let's do the next problem. So rectangles are constructed from square tiles of dimension x centimeter by y centimeter. How many square tiles will be required to construct a rectangle having length of small l centimeter, which is similar to a rectangle of length capital L centimeter and width w centimeter? So rectangles are constructed from square tiles of dimension x centimeter by y centimeter. Okay, so there are some square tiles. Let's say this is x and this is y. Now we are constructing rectangles. From these square tiles. I'm just roughly drawing a rectangle constructed from these square tiles. So let's say for this rectangle, if these are the square tiles, we can say that the width of this rectangle will be obviously 3y, since the width of each square is given to be so the tiles are of dimension x centimeter by y centimeter. So x means length and y means height or width or breadth. So this will be 3y and this will be, how many square tiles are there? Horizontally there are 4 and there are vertically 3 square tiles. So this will be 4x. I'm just as an example. So if this is if this is the rectangle that we constructed using the square tiles, then its length will be 4x and width or breadth will be 3y. Okay. Now it is saying that how many square tiles will be required to construct a rectangle having length of L centimeter, which is similar to a rectangle of length L centimeter and width W centimeter. Now we need to first understand what is meant by similar rectangles. Now similar rectangles means so if this is a rectangle, they look similar but their dimensions are different. That means that if this is a rectangle, let's say R1, this is rectangle R1, let's say the length of this rectangle is, let's say P, and let's say the width or the height is Q. Let's consider another rectangle. Let's consider another rectangle R2, which is similar to R1, and let's say the width or breadth of this rectangle R2 is let's say this over here, this is, let's say the width of the rectangle R1 is P1 and the width or breadth of the rectangle R1 is Q1, and let's say the length of the rectangle R2 is P2, and let's say the width or breadth of the rectangle R2 is Q2. Now if R1 and R2 are similar, if R1 and R2, I hope you know about, you're familiar with figures being similar. If R1 and R2 are similar, they look similar but their size are different. If R1 and R2 are similar, this will imply that the ratio of the corresponding dimensions will be in direct proportion. The corresponding dimensions will be in direct proportion. By that I can see. By that I mean the length. By that I mean the ratio of the length of R1 of the rectangle R1 and the rectangle R2 will be equal to the ratio of the width of the rectangle R1 and the width of the rectangle R2. So you can consider it as this. So this is the definition of the similar rectangles. Okay. Now let's say if I consider let's say a P to be the quantity length of rectangle, length of rectangle, length of similar rectangles, length of similar rectangle, and let's say if Q, small q, represents the width of similar rectangle. Now so now if we consider different values of P and Q, then so P is representing the length of similar rectangle and Q is representing the width of similar rectangles. Now if we give different values to P and Q, we will get different rectangles, but remember that all these rectangles are similar. So for that in that case we must have P and Q will be directly proportional to each other. This will imply P by Q will be a constant. It will be a constant, some constant, which is known as the constant of proportion. So this means that if you consider a few rectangles, similar rectangles, then if you take the ratio of their length and breadth, the ratio will be same. It will be the same constant for all the similar rectangles. Okay, now if I consider a table P and Q, it is given that how many, first we are trying to find what will be the dimension of the rectangle whose length is small l, uh, and which is similar to a given rectangle of length capital L centimeter and width W centimeter. First we need to find the dimension of the rectangle whose length is given as small l centimeter. So it is given that the rectangle is having a capital L centimeter and width W centimeter. So we can consider now the units of this will be definitely centimeter. So we can consider the value of P as L and Q as W. So this is given. Now it is asking what will be, so we need to find the dimension of the rectangle whose a similar rectangle whose length is given to be small l centimeter. So P is L. We need to find the width of the rectangle whose length is L. So let's say we assume this we assume the width of the rectangle having small l centimeter as Q1. So we must have L by W should be equal to L by Q1. So this implies from here we can find Q1 is equal to L W by capital L, smaller w by capital L. This is Q1, that is the width of the rectangle, similar rectangle of length L centimeter. Okay. Therefore, we can say that now it is asking how many square tiles will be required to construct a rectangle having length of small l centimeter. Okay, so now we need to find let's now how do we find how many square tiles will be required to form a rectangle? We will divide the area of the rectangle by the area of the square tiles. Then we will get how many square tiles were required to construct that rectangles. So the area, let's find the area of the rectangle, with length L centimeter will be equal to, we know its length is L and its width is, we have found to be LW by L, which is equal to L square W by L centimeter. Here also Q1 will be centimeter. Now sorry, this is not centimeter, this is area, so this will be square centimeter. This will be square centimeter. So this is the area of the rectangle having the length small l and the width of small l W by L. Therefore, a number of square tiles required, number of square tiles required to construct the rectangle of length L centimeter will be equal to the area of the rectangle divided by area of each tile, that is square tile. This is equal to area of the rectangle we have found to be L square W by capital L, and this divided by the area of the square tile, each square tile, which is XY. it is given that the dimension of each square tile is x centimeter by y centimeter. So its area will be xy. So this is equal to L square W by LX LXY. So this number of square tiles will be required to construct the rectangle of length small l centimeter, which will be similar to a rectangle of length capital L centimeter and width W centimeter. So the correct choice is B. B is the correct choice. B is the correct choice. So I have not written if R1 and R2 are similar. This will actually mean that you can say P1 by P2 will be equal to Q1 by Q2. Okay. Let's do the next problem. The speedometer of Pawan's car only shows distance covered in miles. He googled and learned that traveling 50 miles per hour is same as traveling 80 km per hour. How many miles Pawan has traveled if his speedometer shows 200 km? So the car of the Pawan's car, the speedometer, it shows distance traveled or covered in miles. So whatever, so if Pawan travels a certain distance, the distance traveled will be shown as miles. But Pawan did a Google search and he came to know that traveling 50 miles is equal to traveling 80 kilometer. Is traveling 80 kilometer. Now the question is how many miles Pawan has traveled if his speedometer shows 200 kilometer. Now the question is incorrect. If his speedometer shows 200 kilometer, how can the speedometer shows 200 kilometer when it says in the first line the speedometer of Pawan's car only shows distance covered in miles? So it must be that the speedometer of Pawan's car only shows distance in kilometer. I'm sorry, this is my mistake. I was framing the question, so I incorrectly wrote the first line. The first line will be the speedometer of Pawan's car only shows distance covered in kilometer. So it is asking if Pawan has traveled a certain distance and the speedometer is showing 200 kilometer, then what will be that distance in miles? This is what the question is asking. Now, and it has given the fact that traveling a distance of 50 miles is 50 miles per hour is same as traveling 80 kilometer per hour. This actually means, so 50 kilometer per hour is equal to 80 kilometer per hour. This means that 50 kilometer is equal to 50 miles. This is 50 miles. 50 miles per hour is equal to given to be 80 kilometer per hour. So we can say from this fact we can say that 50 miles is equal to 80 kilometer. Okay. Now one thing, the concept that you need to understand is that if a certain distance in miles and the certain distance in kilometer, they are in direct proportion. So if you consider, let's say x to be the distance in miles and y to be the distance in kilometer, then we clearly understand that since the actual distance, the physical distance is same, the more the distance will be in miles, definitely the more that distance will be in kilometer. That is the if you travel 200 miles, uh, mm, whatever that distance will be in kilometer, and if you travel 400 miles, that value on kilometer will be more. So so we can clearly, now we can say that x varies directly with y. That is, if you consider a specific distance, its value in miles and its value in kilometers, they are in direct proportion. So which means that the ratio of x by y, that is the ratio of x and y, will be some constant. Now if we create a table of x and y, so we know one fact is that 50 miles when the value of distance in miles is 50, the value of that same distance in kilometer is 80. Now the question is asking how many miles Pawan has traveled if his speedometer shows 200 kilometer, which means that we have to say what is the equivalent value of the distance of 200 kilometer in miles. So if x is 200, no sorry, if x is if y is 200, because we are considering the quantity y to be a distance, the value of a distance in kilometer. If y is 200, what will be the value of x? That is, what will be the value of the distance 200 kilometer in miles? So let's say that value is x1. So therefore we can say that 50 by 80 should be equal to x1 by 200. So this implies we can solve x1 and we get x1 is equal to 200 multiplied by 50 divided by 80. This is equal to 8 cancels 200 with 25. So this is equal to 125 miles. 125 miles. So we can say that 200 kilometer is equal to 125 miles. So the correct answer is choice C. Now if I am doing any kind of calculation mistake and I am incorrectly solving the problem, that is I am coming up with a wrong choice due to any kind of mistake in the calculation, please do let me know in the comment section. I will appreciate that, because I am not really focusing that much in any kind of calculation mistake, but I am really focused in applying the correct concept to solve the problem. Okay, let's do the next problem. Question number 4 says, if x square varies inversely with y, that is x square and y are in inverse proportion or variation, then by what percent will y increase or decrease if x is increased by 20%? Okay, so we are having x square, the quantity x square is varying inversely with y. So we have x square varies inversely with y is this. Okay, so we know that for two quantities, if they vary inversely with each other, their product is a constant. So we must have x square y is equal to some constant. We don't know the constant, but it will be some constant. Okay. We are assuming that constant to be k. Okay. Now let's say, so we can say when the quantity the actual quantities are x and y, but it is given that the square of the quantity x varies inversely with the quantity y. So that is why we are having x square varying inversely with y. So x square y is a constant and we are assuming that constant to be k. Now let's say, what if, so we are having x square y is equal to k, where y is the value of the quantity y and x square is the value of the quantity x. Now it is saying then by what percent will y increase or decrease if x is increased by 20%. Okay. Now let's say what will the value of x be if it is increased by 20%. So value of x after 20%, I'm using the symbol, this means increase. Value of x after 20% increase will be equal to 100 plus 20. This is a concept of percentage multiplied by x. So if you increase x or any number, if you increase any number by 20%, that increased number becomes 100 plus 20 divided by 100 multiplied by that number. So when x is increased by 20%, the increased value of x is 100 plus 20 by 100 multiplied by x. This is equal to 120 by 100, and this is equal to 120 by 100 multiplied by x. After simplification, this becomes 6x by 5. Okay. So the value of x after when it is increased by 20% becomes 6x by 5. Now let the value of y be y1 when x is 6x by 5. When x is 6x by 5. Okay. So now we are having two corresponding values. We are having two corresponding values. If you consider the table, we are having x and y. Now I think it will be better to understand if we consider. So we know that x square y will be a constant. So let's say let x1 and let x1 y1 be initial value of the quantity x and y. Initial value of x and y respectively. Now let's say the value of x1 is increased by 20%. So value of x1 after 20% increase will be this will be x1, this will be x1, this will be x1. Now assume that when the value of x1 has become 6x1 by 5, let that then the corresponding value of y is y2. So let's say this will be y2. Let the value of y be y2 when x is 6x1 by 5. So now if you consider the table, it will be like we have initial value was x1 y1. So these are the first initial corresponding values. Next corresponding values is that x1 was increased by 20%, and that is it became 6x1 by 5, and we are assuming that the value of y when the value of x is 6x1 by 5 to be y2. So since we know that x square y is a constant, we must have x1 square y1 is equal to 6x1 by 5 square by 2. Okay. So from here, if you simplify further, we have x1 square y1 is equal to 36 x1 square by 25 y2. Now x1 square cancels out from both sides and we get y2 is equal to 25 by 36 y1. So we get the value of y2 in terms of y1. Now the question is asking, then how then by what percent will y increase or decrease? Okay, so now we need to find that by how much by how much. So now we need to compare the value of y2 and y1 and see whether y2 is more than y1 or not, y2 is more than y1 or less than y1, and we need to find that what is the percentage by which y2 is less or more than y1. Now clearly we can see that y2 is equal to 25 by 36 multiplied by y1. So this will definitely be less than y1 because the fraction 25 by 36 is a proper fraction and any proper fraction is less than 1. Okay. So we can say that y2 is less than y1 by how much? By y1 minus y2, which is equal to y1 is y1 and y2 is minus 25 by 36 by 1. This is equal to if you take y1 common, we have 1 minus 25 by 36. This is equal to 11 by 36 by 1. So y2 is less than y1 by 11 by 36 by 1. So now we need to find what is the percentage of 11 by 36 by 1 of y1. So it is asking that by what percent will y increase or decrease. That is, we need to find what is the percentage by which y2 is less or more than y1. We have already found that y2 is less than y1 by 11 by 36 by 1. So we can say that percentage by which y2 y2 is less than y1 will be equal to the difference of y2 y1 and y2 is 11 by 36 by 1, 11 by 36 y1. So this is the amount by which y2 is less than y1 and we need to find the percentage of this amount based on y1. So y1 and multiplied by 100, this much percentage. So this is equal to y1 will get cancelled out and we will have 11 multiplied by 100 divided by 36, this much percentage. By this much percentage y2 will be less than y1. Now this is equal to if we do a little bit simplification, do cancellation by 4, this will be 9 and this will be 25. 25 multiplied by 11, how much is 25 multiplied by 11? 275. So we have 275 divided by 4 percentage by which y1 y2 is less than y1. That is, by this percentage the quantity y will decrease. Okay, now what is the value of percentage 275 by 4? We have to express this as a mixed fraction. So this will be oh, this is not by 4 but 275 by 9. So we have 3 30 and 5 by 9%, there will be a decrease, 30 and 5 by 9. So the quantity y will decrease by by a percent of 30 and 5 by 9. So the correct choice is D. D is the correct choice. Okay, let's do the last problem. If x varies directly with y, with k1 as constant of proportional, it should be proportion, and y varies inversely as z with k2 as constant of proportion, then how do the quantities x and z vary with each other, and what is the constant of proportion? Okay, so we are given x varies directly with y, or x and y are in direct variation, with the constant of proportion being k1. So this implies that the ratio x by y is equal to k1. This constant of proportion is given. Also, it is given that the quantity y varies inversely with the quantity z. Y varies uh, inversely with z with the constant of proportion k2. So this implies we will have yz is equal to k2, which is a constant, given constant. From these two facts, we have to tell whether how are the quantities x and z related, that is, how do they vary with each other, the quantity x and z. Now if you consider this to be result 1 and you consider this to be result 2, result or equation you can say, if you multiply these two results, that is, when you multiply two equation, what we do is we multiply all the LHS and we multiply all the RHS, and then we equate these to each other, that is, we equate the product of all the LHS with the product of all the RHS. So from 1 multiplied by 2, that is, when we are multiplying these two results or equation, we are multiplying all the LHS, so x by y multiplied by yz, this will be equal to, we will then multiply all the RHS, that is k1 and k2. This implies if you simplify the left hand side, it becomes xz is equal to k1 and k2. So we are having that the product of the quantity x and z is coming out to be a constant k1 and k2. This is a constant because both k1 and k2 will be a constant, as k1 and k2 are constants. The product of two constants is also a constant. So from this we can clearly say that now you can consider the constant k1 and k2 as another constant k3. Another constant k3. So k3. Now when the product of two quantities is a constant, we know that they vary inversely with each other. So we can now say that the quantity x and z vary inversely with each other. So we can say x varies inversely with z, and also we can say that the constant of proportion is k3, which is equal to k1 and k2. So this is the result that we obtained on the this is how the quantities x and z are varying with each other, that is, x varies inversely with z with the constant of proportion being k1 and k2. So the correct choice will be choice D. Correct choice is D. So this brings to an end in solving another 5 good problems on the chapter of direct and inverse variation or proportion. If this video was beneficial, then please like it, share it with your friends, And once again, please support me by subscribing to my channel and do not forget to press the bell icon so that you will be notified by my future videos. I will keep on making more videos on this chapter of 5 good problems on this chapter of direct and inverse proportion in this playlist, that is Maths 8 Hot. So please keep an eye on this playlist and also keep an eye on the other playlist, that is Maths 8 CBSE Maths 8 RS Agarwal, where I will soon start the next chapter, that is polygons. I'm still working, I'm still studying the chapter. I am not yet ready to prepare any video, but I will do it very soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.